These two Starlink satellite dishes are bonded together, meaning that if I'm watching Netflix or if I'm running a speed test or hosting a live stream in a remote location, I not only get the failover capabilities of multiple internet connections, but I can also take advantage of the aggregated bandwidth of both of these satellite dishes simultaneously.
The magic that makes this happen is called SpeedFusion, and it lives here on this Peplink router. Now this model is the B15G, but SpeedFusion is available across Peplink's full lineup of routers. And maybe the thing that's most impressive is that in the time that it took me to do the intro to this video, I could have already had SpeedFusion configured and working to bond my internet connections together. Don't believe me? Well then let's dig in and take a closer look at Peplink's SpeedFusion VPN. Here at Crosstalk, we've been using Peplink routers with our own customers for ages, which is why I was super happy when they reached out to us to sponsor this video. Our first Peplink video was way back in July of 2018 when they still had their PepWave branding. Now these days they're just known as Peplink. We use them here at Crosstalk because they've proven to be rock solid when connectivity is crucial for mission-critical deployments. One of my personal favorite Peplink deployments was during COVID. We were contacted by a television production company that was working on a new show. Now I'm under NDA, so I can't tell you what show it was, but you have definitely heard of it. And man, I wish I could have been there myself to oversee that network. The production was filming in an extremely remote area of northern Canada, where some of the filming locations had access to a wireless ISP, but most didn't. LTE was spotty at best, but it was still critical that they had solid internet connectivity for COVID-19 screening data, for sending clips of whatever was being filmed to remote producers, as well as for emergency communication. So we set them up with what's known as a PACE plan for communications, PACE being primary, alternate, contingency, and emergency. The core of the network was Peplink with dual Starlinks, as well as a tertiary Iridium satellite and LTE SIMs from different cellular providers. And we combined all of that with whatever wireless ISP connectivity might have been available at each location. Now they used this setup throughout the entire filming process and everything worked perfectly. We've also seen Peplink routers used to bond up to 12 Starlink satellite dishes simultaneously aboard Royal Caribbean cruise ships. The Peplink device at the core of that deployment is the Balance 2500 EC, which is an absolute beast of a router. All right, so let's talk about bonding internet connections together. The first question is, what's the difference between bonding and load balancing? Load balancing, most simply, is just a way to distribute your internet load between multiple internet connections for redundancy and scalability. The outbound requests of your clients are then distributed across these connections based on a set algorithm. Usually that's going to be like round robin or least used connection or a weighted distribution based on the available bandwidth of each internet connection. Client connections are then typically persistent to whichever internet connection they land on, and each client's maximum total throughput is limited by whichever link they're load balanced through. Bonding, on the other hand, is more robust. The bonding in Peplink is known as SpeedFusion, and it's not only used for redundancy and scalability, but it's also used for aggregating the bandwidth of your internet connections together for higher total throughput and some more advanced features that I'm going to talk about in just a moment. But first, how does SpeedFusion even work? With SpeedFusion, each client session is broken down into packets and then encrypted into a VPN tunnel. The packets are split between the available internet connections and sent through that VPN to another Peplink endpoint, which receives the packets, reassembles them into their original session, and then sends them out to the internet. The Peplink endpoint on the receiving side can be a virtual or bare metal server that you configure and manage yourself. It can be another Peplink router, or you can use Peplink's built-in SpeedFusion Connect, and that's what I'm going to show you in this video. Since SpeedFusion breaks up your client sessions into their individual packets, the potential bottlenecks from a single internet connection are gone because those packets are sent across multiple different internet connections. And this is great for remote areas where the signals are spotty, or if you're in a moving vehicle. You can combine Starlink, a local wireless ISP connection, perhaps even multiple LTE SIM cards, and aggregate all of those connections together. You can also get more advanced with SpeedFusion. I mean, one of the features that I love is called smoothing. Now, we have a client that has a portable network infrastructure with a Peplink router, multiple Starlink dishes, as well as LTE as a backup. And they do live streams from sporting events. And as we all know, when you're live streaming, if there's any packet loss at all, you're gonna get jittery video. To help prevent this, you can enable smoothing on your SpeedFusion connection. Now, what smoothing does is it sends redundant packets through multiple internet connections simultaneously, which means if a packet doesn't make it through one internet connection, there's a backup of that packet that arrives through a totally separate internet connection. Smoothing, of course, is going to increase the amount of bandwidth being used, but when you're live streaming an important event, typically the bandwidth being consumed isn't nearly as important as having a clear, uninterrupted connection. Another great use case for SpeedFusion is hot failover. Now imagine that you were load balancing two internet connections and you were making a voice over IP call, or you had a Zoom meeting going. You're gonna be load balanced to one of the available internet connections, and you're gonna be persistent to that link. So then in the middle of the call, if that internet connection goes down, your call's gonna get interrupted, and it's gonna take some time to reestablish that connection through the redundant internet link. But with SpeedFusion, your packets are already split between those available internet connections. So if one of the internet links goes down, your call continues down the other link as if nothing happened. You don't actually lose your session. Okay, so enough talking. Let me show you SpeedFusion in action. For this demo, I'm going to be using the Peplink B15G. Now, this router is designed for the SOHO market. It features 4 gigabit LAN ports, 2 gigabit WAN ports, 2 SIM card slots for 5G cellular, and an integrated 2x2 Wi-Fi 6 access point for your client devices. MSRP for this model is $599, but if you're just looking to load balance multiple Starlink dishes, you can get the B1 without the cellular capability for $299. I should mention also that Crosstalk Solutions is an authorized Peplink Gold partner. So if you have any questions at all about which Peplink hardware is right for you, give us a call and we will be happy to find the best fit for your individual use case and budget. And while this device is designed for the SOHO market, Peplink has devices scaling all the way up to large enterprise. Logging into the B15G, we can see a lot of what's going on just by looking at the dashboard. This top section here shows us our WAN connections, and these are grouped by priority. Priority 1 are my 2 Starlink dishes, followed by my T-Mobile 5G cellular SIM card as priority 2. If I don't have SpeedFusion enabled, this is just going to do load balancing. Now notice, for instance, I can just drag and drop my internet connections around between the different priority levels. So if I wanted Starlink Gen 3 to be always on, we'd leave that as priority 1, we'd use Starlink Mini as priority 2, and then we'd set cellular as priority 3. Meaning that I've now disabled load balancing and instead set up failover between these 3 connections. So configuring load balancing and failover is literally just that easy. But of course, you can also dig deeper into the advanced settings to configure the available bandwidth of each link. For weighted load balancing, you can set the connection methods such as DHCP or static. You can configure your DNS settings and on and on and on. Everything that you would possibly need. Notice down here in the disabled section, we've got options for Wi-Fi WAN on 2.4 gigahertz and 5 gigahertz, which means that you can use any Wi-Fi signal as a WAN source as well. For example, if you're working out of an RV and connectivity is mission critical, you could configure the B15G to use the campground's Wi-Fi as WAN, along with your 2 satellite dishes, all bonded together with SpeedFusion, and you still have your 5G cellular as backup. Your internet is just not going to go down in that situation. Further down, we can see the status of our Wi-Fi 6 access point, which we can configure by clicking on the AP tab up in the top. Now, if you guys want to see a full video on how to configure these Peplink devices start to finish, Let me know down in the comments below. Below that, we have SpeedFusion Connect status. And notice that currently we have 3 established VPN tunnels. In my case, they're going to 3 different endpoints. We've got Seattle, San Francisco, and San Jose. Not only do I have redundant Starlink connections for my internet traffic, I'm sending that traffic to multiple different data centers to ensure that all of my packets are delivered successfully. Let's do this though. I'm gonna wipe out all of my SpeedFusion settings, and then we're gonna start the SpeedFusion setup from scratch so that you can see how easy it is. Okay, so now if we look at the dashboard, we can see that my SpeedFusion Connect status indicators are gone. So if we click on the SF Connect tab up at the top, and then we click on Client Mode, this is where I can pick which data centers I want to connect out to for SpeedFusion. Now you see right here it says to get suggestions for the cloud location based on your latency, click here. So if I click that link, it looks like it automatically picked Vancouver, Canada. Now, if I don't want my packets going into a different country, I can drop down the box and we can see all of the different suggested SpeedFusion Connect locations. In this case, I'm gonna pick Seattle as the first link. And then we can hit the green check mark to allow that connection to be established. And just like that, I now have 1 SpeedFusion link established. So let's click this link again. And now I can pick San Francisco. Green check mark, now I have 2 links established. And then finally, one more time, and we're gonna pick San Jose, green check mark, and we're done. All I have to do now is click Apply Changes, and if we click back to the dashboard, I can see that SpeedFusion Connect has already established the link out to Seattle, and it's now working on creating tunnels for San Fran and San Jose, which it just finished as I was speaking. So now all 3 of my SpeedFusion Connect links have been established. Now if I want to get some more detail, I can click on Status and SpeedFusion VPN. And now I can see latency and other statistics for each one of those SpeedFusion connections. But how do I know if this is even working? Well, to do that, we can simply just throw some traffic out to the internet. So if you click on Status and then Real Time, we can see our live traffic. Notice at the top here, we have aggregated transfer. That's gonna be the total throughput through the SpeedFusion VPN. Below that, we can see separate graphs for both of my Starlink dishes as well as the T-Mobile 5G cellular connection. When I run speed tests through the Starlink Mini, I typically get between like 50 to 150 megabits of download. With the Starlink Gen 3, we typically see between like 80 megabits and 300 megabits. But Starlink speed tests can fluctuate a lot, given that they're connecting to low Earth orbit satellites that are flying by overhead at close to 5 miles per second. And that's one of the main issues with using Starlink for live streaming, for voice over IP, or for Zoom calls. But when we're using SpeedFusion Connect, our packets have redundant paths to the internet. So not only do we mitigate any fluctuations in satellite bandwidth, we also aggregate those 2 connections and receive more consistent speeds than either one of the Starlink satellite dishes provides on their own. And this is especially important to achieve more total bandwidth as well as a more consistent connection on the upload side for live streaming or just for sending traffic up to the internet. So now let's go ahead and run a speed test and then watch the graph. Okay, running my speed test. And notice that the graph for both of these Starlink connections is going to peak out at around 100 megabits. The B1 5G, when used as a router without SpeedFusion enabled, has a maximum throughput of 1 gigabit per second on the WAN side because it has gigabit NICs. When you're using SpeedFusion, however, you can choose whether or not you want to encrypt your links. By default, the unencrypted links can achieve an aggregated 400 megabits per second, and encrypted links can hit 200 megabits per second. And if you need more bonded throughput than the B1 provides by default, Peplink has plans that can boost not only your total throughput capacity, but also your amount of allocated data. Now, if we click back into SF Connect, let's look at some of the outbound traffic steering priority options. These settings allow you to get more granular with your outbound traffic. So if you choose Route by Cloud Application, this lets you pick from popular cloud applications like Google Meeting, Zoom, or Microsoft Teams, and then you can pick which SpeedFusion link that traffic is assigned to. You can also route the SpeedFusion traffic based on the wireless SSID that your clients are connected to, or you can route individual LAN clients by MAC address. So again, just a lot of ways to get really granular with which of your clients are using the SpeedFusion Connect and which are just going maybe straight out to the internet with standard load balancing. Now, it's rare that a feature so powerful is made this easy, but that's exactly what Peplink has done with SpeedFusion. Now, we've been using Peplink devices with our own customers for over 6 years now, and I can tell you firsthand just how useful these features are for mission-critical applications where the internet just can't go down. And again, Crosstalk Solutions is a Peplink Gold certified partner, so be sure to contact us if you have any questions at all about the Peplink lineup of products, about SpeedFusion, or if you'd like us to design and build a solution for your organization. Thanks again to Peplink for sponsoring this video, and if you'd like to keep this party going, I have hand-selected a couple of videos on the right here for you to watch next. The top video is my recent setup and review of Starlink Mini. And the bottom video is a look at the WLAN Pi, which is a super powerful Wi-Fi multi-tool.